Hello friends, welcome back. Hearty welcome to you. As part of coordinate geometry pair of straight lines, let us look at this interesting problem and try to solve it together. Prove that the distance from the origin to the orthocenter of the triangle formed by the lines x by alpha plus y by beta equal to 1 and ax square plus 2hxy plus by square equal to 0 equal to, this is what we have to prove it. So let's try to understand the problem first. Let us say that these are our two coordinate axes, x positive and y positive. We have a line x by alpha plus y by beta equal to 1. That is the line x by alpha plus y by beta equal to 1. And we have another pair of straight lines. We have one line and pair of straight lines. The pair of straight lines is given by ax square plus 2hxy plus by square. Let us say that pair of straight lines can be written as combination of two lines, as you know. We'll write down here that can be written as, this can be written as L1x plus M1y into L2x plus M2y equal to 0, as we are passing through origin 0, 0. So this can be written. So we have two more. We have one line x by alpha plus y by beta equal to 1, and these are pair of straight lines which is given by L1x plus M1y into L2x plus M2y equal to 0. So this line is L1x plus M1y equal to 0. The other line is L2x plus M2y equal to 0. So we are just trying to understand what the question is. So we have to find out, what we need to find out is the distance from the origin to the orthocenter of this particular triangle. So let's try to label them. We'll say this is O, we'll say that's A, and this is B. Now what's the meaning of orthocenter? Orthocenter is nothing but point of intersection of perpendicular altitudes, can I say? So this is one altitude, there is another altitude. So this is the orthocenter, this is the orthocenter. Let's give the coordinates names. Let us say A is x1 comma y1, and this we call it as orthocenter. Let us say, we can take any name for that. Let us say H. We have those coordinates as x0 comma y0. So let's try to recap what we have done so that we can understand what to do now. We have to prove that the distance from the origin to the orthocenter of the triangle formed by the lines x by alpha plus y by beta equal to 1 and ax square plus 2hx square plus by square equal to 0 is that. So what we have done, the first thing is, we know x by alpha plus y by beta equal to 1 is this line. Now we have taken the ax square plus 2hx square plus by square equal to 0 into two lines. One line is L1x plus M1y equal to 0, another line L2x plus M2y equal to 0. We have done enough problems on this, so you should be very comfortable with how we can write that. And what are the conditions at that time? If you compare them, we will get L1 L2, we will get L1 L2 equal to a square, M1 M2 equal to b square, comma L1 M2 plus L2 M1 is equal to 2h. So these are the what we know already. Okay, So what is the approach we have to follow now? So let's try to understand the steps. I have to find out the distance from the origin to the center. That means first I have to find out what is the coordinates of orthocenter. If I want to find out the coordinates of orthocenter, I have to find out the altitudes, because orthocenter is point of intersection of altitudes. So if you want to find out the altitudes, then you have to know all the equations and also the vertices. At least 2 vertices we should know. Lucky for us, we know one is 0, 0. So we know that if we can able to find out coordinates of A, then I know the equation of OB. I should be able to find out, let us say this is X and this is Y. AX, OY are the altitudes and H is the orthocenter. We have to find out distance OH. So let's write down that what we have to find out is distance from origin to the orthocenter. Our orthocenter is H x0 comma y0. Origin is O 0 comma 0. So the distance is nothing but square root of x0 whole square plus y0 whole square. Now you want to find out x0 y0. I should know equations of Ax, comma I should also know the equation of Oy. To know the equation of Ax, I should know the equation of OB, which I know already, and I have to know the point A. A coordinates I need to know, and to get Oy I have already 0, 0 with me. I know the equation of AB. So Oy I should be able to get easily. Oy I can get AB, I can get Ax, then point of intersection is H. Once I get H, OH equal to square root of x naught square plus y naught square. So we will start with first trying to find out the equation of altitudes. Then the point of intersection of altitudes is nothing but the orthocenter. Then the distance from 0, 0 to orthocenter x0 comma y0 is root of x0 square plus y0 square. So let's go ahead and do step by step. We'll try to finish it quick. First we will work on altitude Oy. For Oy I know point is O is 0 comma 0, and I know equation of AB. Equation of AB is beta x by alpha plus y by beta equal to 1, or can I write it as beta x plus alpha y equal to 1. Now what is Oy? Oy is perpendicular to AB. So AB equation is beta x plus alpha y equal to 1. Then this will be alpha x minus beta y plus k equal to 0. But since it passes through 0 comma 0, the equation of Oy will be alpha x minus beta y equal to 0. So let's write down that Oy equation is, maybe I'll write down some other place. We'll write down Oy equal to beta x minus alpha y equal to 0. We'll write down here Oy equation is alpha x minus beta y equal to 0. Now let's go ahead and try to find out the equation of other altitude, that is Ax. Remember, to find out the Ax, first I have to find out the point A, then only I can go for Ax. So let's go to Ax and try to find out the altitude of Ax. For Ax, first we'll try to find out coordinates of A. Coordinates of A are given by point of intersection of OA and AB. OA and AB. OA is L1x plus M1y, L1x plus M1y plus 0 equal to 0, and AB is beta x plus alpha y minus alpha beta equal to 0. Now we want to find out coordinates of A, that is x1 and y1. So for that, what we will do, we'll use cross multiplication and we'll try to solve it. So we know that x divided by A1 B1 C1 B1 C2 minus B2 C1. Can I write down? Minus M1 alpha beta. We are using cross multiplication method here. Y divided by C1 A2 minus C2 A1, that is L1 alpha beta, is equal to 1 divided by A1 B2 minus A2 B1, that is L1 alpha minus M1 beta. So we can write down x1 is equal to M1 alpha beta. I take that negative and multiply. I can write down, or I can keep it as minus. It is L1 alpha minus M1 beta, and y1 is equal to L1 alpha beta divided by L1 alpha minus M1 beta. This is my x1 and y1. Now once we know coordinates of A, we know the equation of OB, so we should be able to find out the equation of AX. So once we know AX and OY, we can easily find out what is H. Once we know H, OH, we should be able to find out. So what we found out now, just OA, AB point of intersection, that is A. Now you want equation of AX. Equation of AX is nothing but, you know, equation of OB, L2x plus M2y equal to 0. So the AX equation will be M2x minus L2y plus k equal to 0. But that line is satisfied by point A. That we will use and try to find out what is the equation of the AX, line AX. Then we know OY. You should be able to find out what is coordinates of H. So let's move. Now let's go to equation of AX. We want equation of AX. Equation of AX will be perpendicular to OB. OB is perpendicular to OB. OB is L2x plus M2y equal to 0. So AX will be of the form M2x minus L2y plus k is equal to 0. That's a simple equation which is perpendicular to given line. Now we know that x1 comma y1 satisfies it. So I can write down x1 comma y1 is a point on this. So I can write down m2x1 minus L2y1 plus k is equal to 0. Now we'll substitute whatever the values we got for x1 earlier and y1. We'll substitute that and we'll see what happens. We get m2 into minus m1. So I can say minus m1 m2 alpha beta divided by L1 alpha minus m1 beta minus L1 L2 alpha beta divided by L1 alpha minus m1 beta plus k is equal to 0. What is that we are trying to do now? We are trying to find out the equation of AX. If we simplify this, we will get k equal to L1 L2 plus m1 m2 into alpha beta divided by L1 alpha minus m1 beta. Substituting k value, we get our equation of AX. AX is nothing but now m2 x minus L2y plus k. L1 L2 plus m1 m2 is nothing but, we know, that is a plus b, that is a and b, my mistake. You compare them, it's a and b. So can I write down a plus b into alpha beta divided by L1 alpha minus M1 beta. This is the equation of AX. AX equation, altitude equation of AX. Another equation we know already for OY. OY equation, we know that that's nothing but alpha x minus beta y equal to 0. Now these 2 points are satisfied by orthocenter. These 2 points are satisfied by orthocenter. This is altitude AX, equation is given by this. This is altitude OY, equation is given by alpha x minus beta y equal to 0. These two straight lines, point of intersection is orthocenter. Orthocenter satisfies both the equation. That means x0 comma y0 satisfies both of them. So by that I should be able to find out what is the value of x0 and y0. Let's move. Now since x0, y0 satisfies both of them, I can put down x0 here, I can put down y0 here, I can put down x0, I can put down y0 and solve for x0 and y0. So let's do that. Out first x value, so I'll write down m2 x0 minus L2, I'll write down as it is, y0 is nothing but alpha into x0 by b beta is equal to, I can take right hand side to left hand side, I will have a plus b into alpha beta divided by m1 beta minus L1 alpha. So what we have done, we have just taken this to that side. Since it becomes minus, I have multiplied here so that I don't put the minus side. So we have m2 x0 minus L2 into alpha x0 by beta is equal to a plus b into alpha beta by m1 beta minus m1 alpha. From this we should be able to find out x0 value. Can I take common there and write down x0 into m2 beta minus L2 alpha divided by beta is equal to a plus b into alpha beta divided by whatever we have there, that is m1 beta minus L1 alpha. We can go ahead with that. So let's go to the next step and find out from this what is x0 value. That gives me x0 is equal to, next step will be alpha beta square into a plus b divided by, we have m1 beta minus L1 alpha, and that I have to multiply with m2 beta minus L2 alpha. This is the last step. After last step, what we will get now? We try to simplify this. We find out that alpha beta square into a plus b, and this when I multiply, I will have L1 L2 alpha square plus m1 m2 beta square. After that I have minus alpha beta into L1 M2 plus L2 M1. So can I write it as alpha beta square into a plus b divided by, we know L1 L2 is nothing but equal to a, M1 M2 is b, so we can leverage that. I can write down a alpha square minus 2h alpha beta plus b beta square. This is my x naught value. So based on this I can find out what is y naught value. We know that alpha x naught is equal to beta y naught. Therefore simply by that we know y0 is equal to alpha by beta into x naught, which is nothing but alpha beta square into a plus b divided by a alpha square minus 2h alpha beta plus b beta square. Simplify that, we will get alpha square beta into a plus b divided by a alpha square minus 2h alpha beta plus b beta square. Now we have our x0 and x0 and y0, x0 y0, we have both of them, so we should be able to get our distance from origin to the x0 y0, that is nothing but square root of x0 square plus y0 square. That will be our last step. The distance what we need to find out is, as we have noted, is square root of x0 square plus y0 square. Now we substitute the values, we get alpha square plus beta square square root and multiply that with a plus b into alpha beta divided by a alpha square minus 2h alpha beta plus b beta square. So we know x0, we know y0, we square it up. You can see that alpha beta square whole square plus alpha square beta whole square. I can take alpha square beta square out, it becomes alpha beta. Left out is alpha square plus beta square in square root. We have a plus b and this remaining as it is. So this is what we need to prove. So let's take couple of minutes to try to summarize this, what we need to do. We have been given that there is a pair of straight lines and there is another line. They form a triangle. We need to find out the distance from origin to its orthocenter. The first thing first, we know it's a second degree homogeneous equation, so we converted that, we have written it as combined equation of two pair of lines, pair of straight lines. So two lines we have taken it, and we know the conditions, L1 L2 is A, M1 M2 is B, and L1 M2 plus L2 M1 is 2H. Now we have to find out orthocenter, means we have to find out point of intersection of altitudes. First we need to find out altitudes. To find out the altitude, I need to know the opposite equation perpendicular to which altitude is perpendicular, that's a side, and I need to have opposite vertex. Side opposite vertex. Once for O I know 0 comma 0, A I have to find out. So I have to use cross multiplication and find out A. Once I know A, I know OB equation, so I can find out AX equation. I know OY equation, solve them together, you find out x0 comma y0. Now what we need to find out is square root of x0 square plus y0 square. That's one interesting problem, but it's a bit lengthy problem I thought of sharing with you. Please do let me know your feedback. Thanks for your time and support. Bye for now.